Hello Bobcats. So today in this video we will be discussing oxidation reduction reactions, also known as redox reactions. So a reaction in which electrons are transferred from one substance to another is a oxidation reduction reaction. So a reaction in which electrons are transferred from one substance to another is a oxidation reduction reaction. And so let's look at a reaction and see what I mean by this transfer of electrons. So if I take iron, so iron, solid iron, and we're going to react it with oxygen gas, we're going to produce iron 3 oxide, and that's going to be a solid. And of course we need to balance the reaction, so we have 1 iron, 2, so I can put a 2 here, but this is by itself. So let's look at the oxygens. We have 3 here and 2 here, so those both will go into 6, so I need a 3, so that's 6 oxygens. Then I need a 2, that's 6 oxygens, and 4 irons, so then I need a 4. Now let's look at the charges of each of these substances. Now iron is an element, so it has 0 charge, and oxygen is also elemental, so it has 0 charge, it's neutral. But when we combine them, we know that this is an ionic compound, and the iron is going to be a 3 plus and the oxygen is going to be a 2 minus. So when we look at this, we notice that oxygen is going from 0 charge to 3 plus, so it is losing electrons in its reaction, and we call it oxidation. So oxidation is defined as the loss of electrons by a reacting substance. Now remember, substance can be an element or a compound. In this case we're looking at elements, and so iron is going through oxidation. And we look at this one, oxygen is going from 0 neutral to 2 minus, so it's gaining electrons, and we call that reduction. So reduction is defined as the gain of electrons by a reacting substance. Okay, so oxidation is loss of electrons, reduction is gain of electrons. Now, those terms seem kind of contradictory. If you think about it, reduction to me means that you're losing or reducing something, but in this case we're actually gaining electrons. And the reason then oxidation is lost, where did oxidation come from? Well, the reason these names ended up this way is that before scientists knew anything about electrons, they did these reactions. They would react an element with oxygen and produce a compound. And they noticed that as they did, that element, iron, would gain oxygen. And so that means that in this case, because iron gained oxygen, it was oxidized. And so they used the word oxidation. But later they realized that it's really all about the electrons, not just the oxygen. And so when it came around, they realized that the iron is losing electrons when it gained oxygen. So they just kept the term oxidation as loss of electrons, and then reduction is the gain of electrons. So how do you go about remembering these terms if it seems kind of confusing? So I use a mnemonic called oil, that's an I, oil rig. Okay, so oxidation is loss of electrons, that's oil, and reduction is gain of electrons. So reduction is, let's make that capital I, gain, oil rig. And that's how I remember which one's oxidation and which one's reduction. Now, to do this, we have to have a system of keeping track of the electrons. So the system that we use is called oxidation numbers. And yes, charges can be oxidation numbers, but not all of the oxidation numbers are charges. So let's go through and talk about oxidation numbers, or this system of keeping track of electrons. So oxidation numbers. And shorthand for oxidation numbers, I'm just going to write a capital O, capital N for oxidation numbers. And again, this is a system used to keep track of electrons in a reaction. Okay, and like I said, oxidation charges can be oxidation numbers, but not all oxidation numbers are charges. So we're going to go through rules for assigning oxidation numbers. Rule number 1. An element always has an oxidation number of 0. So let's review up here. Remember, iron is an element, so it has a 0 oxidation number. Oxygen O2 is also elemental, or an element, and its oxidation number is 0. So rule number 2. The oxidation number of monoatomic ions is equal to the charge of that ion. And that's when charges are used as oxidation numbers. Okay? Rule number 3, the sum of the oxidation number of elements in a polyatomic ion is equal to the charge of the ion. And I'll go over that in just a minute. Okay, so with polyatomics, ions, the sum of the oxidation numbers of the elements are equal to the charge of that ion, and for monatomic ions, the oxidation number is equal to the charge of the ion itself. Like if I review back up here, these are monatomic ions. We know they're monatomic because this is a binary ionic compound. So it takes an iron 3+ and an oxygen 2-, and those are the charges of those elements. And I'll go over the polyatomic after I get finished writing all the rules down. So let's go to rule number 4. And rule number 4, the deal is that not all oxidation reactions only occur with ionic compounds. They also occur with covalent. And covalent compounds do not have charges, but they do have oxidation numbers. So the first one is that hydrogen generally has an oxidation number of 1+. Okay, so in our instances, we're just going to say that hydrogen has an oxidation number of 1+. There are exceptions where it's a 1-, but we're going to say 1+. Rule number 5 is that oxygen, so this is hydrogen, oxygen generally has an oxidation number of 2-, okay, except in peroxides. Now, the reason it's important to say this and to give you this is that, think about it, carbon dioxide. Carbon dioxide has 2 oxygens, but it's not an ionic compound, it's covalent. So those elements do not have charges. But the oxygen, we know in carbon dioxide, has an oxidation number of 2-. Or in methane, CH4, it's a covalent compound, but the hydrogen will have an oxidation number of a 1+, even though it is not an ionic compound. And the last thing we need to be aware of is that the sum of the oxidation numbers of a neutral compound is equal to 0. So we're going to use these rules and practice right now. So let's practice determining oxidation numbers for several compounds. Practicing oxidation numbers. Okay, So the first one, let's go ahead and start with carbon dioxide, CO2. Now, just for convenience sake, I'm going to all my oxidation numbers, ON oxidation numbers, we're going to place on top, and then the sums of the numbers we're going to place on bottom, and that will we use the sums to determine the oxidation numbers. Remember, sum of the oxidation numbers must equal 0 on a neutral compound. So let's go through and show you how this works. This is, we know that oxygen, based on rule 5, is going to have an oxidation number of 2-, so that's a 2-. We have to now determine what carbon is. So we're going to get the sum here. So 2- times 2, that's a 4-. Now this has to come out to be 0 on the bottom. And to have a 0, this has to have a 4+. The carbon has to have a 4+. And since there's only one carbon, that carbon's oxidation number is 4+. So we would say that carbon has an oxidation number of 4+, oxygen has an oxidation number of 2-. Let's look at some more. Let's do sodium sulfate. Again, oxidation number on top, sums on the bottom. Okay, so oxygen we know is a 2-, and by the way, a lot of times you can think of it too as that the outer elements on a ionic compound will just be the charges of those elements. It's the center one that you have to figure out that will have a different oxidation number. So we know that sodium, which is a monatomic ion, sodium has an charge of 1+, so we'll say the oxidation number for sodium is a 1+. It's in group 1. Now I'm going to do my sums. So this is 2 times 4, so that's an 8-. Remember, this has to be 0 because it's neutral. Then over here we have 2 times 1+, that's a 2+. So to get to 0, I need a 6+ here. And since this is 1 sulfur, sulfur is a 6+ oxidation number. Let's just show you so you can see that the oxidation number of the center atom can change. Let's look at sodium sulfite. This is sodium sulfate. Let's look at sodium sulfite, SO3. Again, we're going to do we know that oxygen is a 2-, and that sodium is a 1+. So when I do the sums, this will be a 6-. Remember, the sums have to equal 0. This will be a 2+. 1 times 2 is 2+. And so in the center we have to have a 4+ to come out to 0. Since there's only one sulfur, it's a 4+ charge. So you notice that sulfur can be a 6+ or a 4+. Now we call these oxidation numbers, even though we do use charges sometimes to determine oxidation numbers. Now let's look at the third rule. The third rule is about the polyatomic ion. So if we have a polyatomic ion like PO4 phosphate, and it's a 3-, that's a polyatomic ion. Well, we know that it says that the sum of the oxidation numbers for the polyatomic ion must equal the charge. So we know that we have to equal a 3- here. So we know oxygen, based on the rule up here, is a 2-. So 2- times 4 is 8-. And to have a 3- left over, this has to be a 5+, because those two added together gives you 3-. 1 phosphorus means that's a 5+. So phosphorus has an oxidation number of 5+. Oxygen has an oxidation number of 2-. Let's look at a couple more to make sure we're doing well. Let's say I have lithium dichromate. Okay, so when we do lithium dichromate, we have, remember, everything has to come out to be 0 in this because it's neutral, there's no charge. So this is a 2-. 2 minus times 7 is a 14 minus. Then over here, this is a 1 plus, because lithium is in group 1, and it's a monatomic ion, and so that's a 2 plus. So in the center, to get to 0, I need a 12 plus. But because there's 2 chromiums, we take 12 divided by 2. Each chromium has an oxidation number of a 6 plus. So the chromium has an oxidation of 6 plus. Just so you can see also how we would look at methane. This is not a covalent compound again. So when I look at it as a covalent compound, remember in covalent compounds, hydrogen is going to have a 1 plus. So I'm going to go 1 plus, and it's all got to equal to 0. So that's a 4 plus here. And to get to 0, this has to be a 4 minus. And so carbon has a 4 minus oxidation. You notice carbon went here, it's a 4 plus, here it's a 4 minus. These are not charges, these are oxidation numbers. The last one I want you to be aware of is, let's say you have something like I'm trying to think, aluminum sulfate. So aluminum sulfate would be Al2SO4 3. That's aluminum sulfate. Anytime you have multiple polyatomic ions, the best way to do it is to separate them and do the ions individually. So we would look at aluminum, and then we would look at SO4. And SO4 is a 2 minus, so that has to have a charge equal to 2 minus. So when I do this, we know aluminum is a monatomic ion. It's a 3 plus. So it has a 3 plus oxidation number. Here we go 2 times 4, so that's an 8 minus. And to get to a 2 minus, this has to be a 6 plus. So I have a 6 plus and a 2 minus. So when I put I assign the oxidation numbers to this, it's just a 3 plus, a 6 plus, and a 2 minus. But I had to do them separately, okay? So that's good practice for oxidation numbers. Now what we would like to do is use these oxidation numbers in reactions. And how do we determine what element is being oxidized in the reaction and what element is being reduced in the reaction? So I'm going to go through 3 reactions, and we're going to practice with 3 reactions, and then we'll finish off talking about oxidizing and reducing agents. So, determining what elements are oxidized and what elements are reduced in a reaction. Okay, so let's look at reactions. Let's take a simple one to start with. Let's use hydrogen gas plus oxygen gas producing water vapor. Okay, so in this case, that'll be a gas also. We have to balance it, so I've got 2, 2, 2, 1, so I need to put a 2 here, and I need to put a 2 here. Now, the coefficients aren't used for determining oxidation and reduction. We just still need to balance it. Now, as I go through this, hydrogen is 0, oxygen is 0, because those are both elements. They're diatomic elements. And then over here, we know that hydrogen's a 1 plus and oxygen's a 2 minus. Okay. So we notice that hydrogen is going from 0 to 1 plus. So hydrogen is going from 0 to 1 plus, therefore it is losing electrons. And if it is losing electrons, if hydrogen is losing electrons, remember oil, oxidation is lost. Then hydrogen is being oxidized or going through oxidation. So hydrogen is oxidized in this reaction. Or you can say going through oxidation. Either way. Now let's look at the oxygen. So oxygen is going from 0 to 2 minus in this reaction, 0 to 2 minus, and so therefore it is gaining electrons. And by gaining electrons, the oxygen, remember gaining, I should write electrons, gaining electrons. And in gaining electrons, think of rig, oil rig, rig is reduction is gain. So by gaining electrons, oxygen is reduced or going through reduction. Okay, so that's how we look at it. So, and by the way, this specifically is a synthesis reaction. It's also a combustion, but let's look at it as a synthesis reaction. And so synthesis reactions are oxidation reduction reactions. The next one we're going to look at is CH4 plus O2 produces carbon dioxide and water. Okay, so in this case, we have 4 minus, we figured this out earlier, and a 1 plus, 0. This will be a 4 plus and a 2 minus, and then we have a 1 plus and a 2 minus. We had figured these out in the previous page, so that's why I went through it real quick. So when we look at this, we see that carbon is going from a 4 minus to a 4 plus. So carbon is losing electrons, and going through loss of electrons is oxidation, oil, oxidation. So carbon is going through oxidation. Hydrogen is going from a 1 plus to a 1 plus. So nothing happens there. Oxygen, on this hand, oxygen is going from 0 to a 2 minus on both cases, so it's gaining electrons. And if it's gaining electrons, it is going through reduction. So oxygen is going through reduction, and we can see that. Come in. Just hang on a minute when you come in, please. I got to finish this video, so give me a minute and I'll be done. And we notice that this is a combustion reaction. So all combustion reactions go through oxidation reduction. All combustion reactions. So So we have synthesis and combustion. The last one we want to look at is a decomposition reaction. So we're going to take potassium chlorate goes to potassium chloride plus oxygen gas. Oh, and I forgot to balance this up here, so we need to make sure it gets balanced. So we have a 2 there and a 2 there. This one we need 2 here to have 6 oxygens, a 3 here, and then a 2 here. So let's do the oxidation numbers. We have a 2 minus for the oxygen, and then this one, which is monoatomic, potassium, is a 1 plus, and so that's a 6 minus and a 1 plus. That means this has to be a 5 plus to be neutral. And then over here we have a 1 plus and a 1 minus and a 0. So chlorine, in this case chlorine, now let's look at I forgot to look at this. Potassium is going from a 1 plus to 1 plus, so nothing's happening in potassium. Chlorine, though, is going from a 5 plus to a 1 minus, so it's actually gaining 6 electrons. So chlorine is gaining electrons and being reduced. So chlorine is going through reduction, and oxygen is going from a 2 minus to 0, so it's losing electrons. So oxygen is losing electrons and being oxidized, or going through oxidation. Okay, so that is a decomposition, and so decomposition reactions are also oxidation reduction. One last thing I want to mention before we stop this video is that all combustion reactions go through oxidation reduction. Most synthesis does go through oxidation reduction. There are some exceptions, and most decomposition goes through oxidation reduction, but there are some exceptions, and I'm going to show one exception, and it's a very, very important reaction. It's a really important reaction, so I'm going to go through it. It's when we take carbonic acid, H2CO3, which is aqueous, and it decomposes to make water and carbon dioxide gas. Liquid water, sorry, and carbon dioxide gas. Now if we look at our oxidation numbers again, we have a 2 minus and a 1 plus, so that's a 6 minus and 2 plus, so this has to be a 4 plus for the carbon. This is a 2 minus, 1 plus, and then this is a 2 minus, and so 2 times 2 is 2 minus. That means this has to be a 4 plus. And you'll notice that it's a 1 plus to 1 plus, a 4 plus to 4 plus, and a 2 minus to 2 minus. Nothing changes. It is a decomposition, but it's not an oxidation reduction. And so we will end that video on that note. Thank you. Sorry about that.